move that out of the way as well. So hopefully you can all see those slides okay. Yeah, great, thank you. And I'm just trying to see my controls, making sure, yeah, I'm not on mute or anything. So, well, thanks very much everyone for coming along today, and to Tarek as well for inviting me to share this challenge. So my name's Tam. I'm a research fellow on the Smartline Project at the University of Exeter. I'm based on the Penryn campus, and I'm going to talk about the data challenge that we have. If you'd like to see the materials as we're going through, then you can go to tinyurl.com Smartline Cluster Data Challenge, where there are copies of the slides and a demo script. And I will be giving more information about that as we go through, so don't feel you have to go there and have a look now. But first of all, before I describe the challenge, I'm going to give a brief overview about Smartline. And Tarek just clarified we've got about 30 minutes for the session, so I've got about 20-25 minutes of talking. So hopefully that will give time for some discussion and questions at the end. So Smartline is the first project that I'm aware of its kind. It's looking at all different kinds of data to help us understand how we might live healthier and happier lives. The project's funded by the EU Regional Development Fund and by the UK government. The University of Exeter is working with 4 partners: Cornwall Housing, which is our housing association, Coastline Housing, managing thousands of homes across Cornwall, including the 300 homes that are part of our study. Our second partner, Cornwall Council, they're interested in housing-related public health issues such as indoor air quality. Volunteer Cornwall is our third partner, and along with Coastline, they develop and support community-based projects in response to Smartline participants, such as green space projects and IT training groups. The Southwest Academic Health Science Network is a partner that helps us disseminate our findings and maximise the impact of our project with other relevant external bodies. So the project focuses on 3 pillars: supporting small to medium-sized enterprises with research or with funding to help them understand either their market needs or their products, particularly the development of new e-health and e-wellbeing products and services, with the overall aim being to boost the economy in Cornwall. The second pillar is working with and supporting the community, so in conjunction with our partners, as I just described. And the third pillar is producing research. So we have a broad range of researchers: mathematicians, data scientists, epidemiologists, sociologists, economists, all conducting research on the data that we've collected. So it's a large and fairly broad-reaching project. It's been running since 2017 and set to continue until 2022, next year. So as I said, one of the main purposes of Smartline is to support local enterprises, and this map shows just some of the enterprises that we've worked with so far through Emma and James, our knowledge exchange officers. So if you know people in Cornwall who've got their business and would appreciate some research support, then I would recommend you get in touch. So the Smartline project has more than 300 participants from Coastline Housing properties across Camborne, Luggan and Redruth. And they've kindly answered our surveys and have had sensors installed in their homes. From the face-to-face survey, excuse me, with participants, we know, sorry, we know that the majority of our participants are white females. They have an average age of 56. Much of Cornwall has some of the most deprived postcodes in England, not measured just in terms of income and employment stability, but also services that are available. and our Smartline community reflects that, with 54% of participants living in the 10% most deprived postcodes in England. 6% of our participants did not own a mobile phone when we started the study, while 11% owned a wearable device such as a Fitbit, and just over 20% of participants did not have an internet connection at home when we started the study. So as well as these survey data, we have measures from readings from measures from sensors that were installed in end of 2017, beginning of 2018. And they take readings every 3 to 30 minutes. In each home, we've got readings of air temperature, relative humidity, and air quality, including volatile organic compounds, or VOCs or VOCs, which are generated by things like perfumes and cleaning products, and particulate matter, or dust, which is of size 2.5 micrometers. It's called PM2.5. It's about the thickness, 1/20th the diameter of a human hair, or the thickness of a spider's web. PM2.5 can be increased by things like smoking, or open fires, or even just people moving around and circulating dust in the air. And we have external sensors placed outside some homes, again measuring temperature, humidity, and air quality, including PM10. And we have measures of electricity use in the homes, and a few of the homes have water and gas usage measures as well. So altogether, we've got more than 500 million data points from the sensors, with each home having 300,000 readings for temperature alone. My role in Smartline is to work with these sensor data to create models, conduct analyses, to establish differences across different types of homes, or detect anomalies in the data that might be indicative of an underlying problem in the home. Okay, so now I'll go on to a bit more specifics on the challenge. So as you've seen, we've got a lot of data on the Smartline project, and we wanted to make it more accessible, more tangible. And so we decided to create personas to represent our cohort of participants. And these images are those personas. They aren't actual participants, rather each persona represents a group of similar people, and altogether they represent the Smartline cohort, the complete group of participants. And they've provided us a way of explaining our Smartline participants to others, and also for the participants themselves to talk about a given persona without the need to talk about themselves personally. For example, we've had focus groups where we can ask questions like, for example, how do you think Jenny feels about using the internet? And we can acquire views from participants in this way without them talking about themselves personally. So to create these personas, we used a process called cluster analysis, which I'll describe in a moment. And we grouped people together based on their survey responses and some information about the building that they live in. And then on top of those groups, we layered additional information from the sensor data and from qualitative information from a structured interview called a guided conversation. So now I'm going to describe the cluster analysis process and how we used it for creating our Smartline personas. So cluster analysis basically groups items together based on their similarity across a range of characteristics, so that similar items are grouped together and the groups that result are different from each other. So to take a made-up example, we could have two variables about our participants, their age and their score. That could be their mental health score, for example. And we can plot each person by their age and their score, with each person represented by a set of coordinates. So this person has an age of 68 and a value of 32 for the score dimension. And the cluster analysis divides the people into groups that are similar to each other for those factors of age and score, and provides a centre for each of those groups. And the purpose is to create clusters that contain similar individuals. The number of factors that we used for our Smartline participants wasn't just 2, it was more than 50 factors, including a range of measures such as demographics, health, social cohesion, what pets they had, and their household behaviours such as ventilation habits and things like that. So the way that the cluster analysis works is to start with some randomly chosen centres, one for each cluster, and then each individual is assigned to the cluster with the closest centre to that individual. And then the centre is updated to be the average of all the individuals in that cluster. And then that process is repeated iteratively so that the centre becomes more central within the group of individuals, and the distances from the individuals to their centre become smaller. And during that process, individuals might change from one cluster to another. So the average for that cluster and therefore its centre also updates and change. And then the memberships of that cluster will also change as the centres move. But the process continues until the overall distance between the individuals and their centres is as low as it can be without any further changes. So the individuals are in the cluster that is best for them. The most common form of cluster analysis is called k-means, which is based on calculating the means of individuals to create the centres. But there are other types that are based on modes. And for Smartline, we used one called k-prototypes, which uses means and modes. So just to visualize that process a bit, if the video loads. It was working earlier, here we go. So first, the centres represented by different colours are chosen randomly. And then the centre is updated to be the average of the individuals that are assigned to that centre. So the individuals are assigned to their closest centre. And then that process repeats, and we can see the centre becomes drawn in towards the cluster, the bulk of the data points, and the lines, the distances between the individuals and their cluster centre are becoming shorter. So I'll now go to the online materials and run through the kind of demo starting script on cluster analysis there. But I do have to say that by accessing the and using the Smartline data, you're agreeing not to attempt to identify any individual person or home or household in the data set. Right, so I'll just go to that website. Hopefully my screen is sharing as a whole screen so you can still see that. So within this directory, which you should all have access to, there you have the link. There's a copy of the slides. There's an information sheet which has a lot more detail about the clustering process and the challenge itself. And then under data, we've got the survey data from the participants, a copy of the questions that people were asked, so you can relate the survey to the questions. The sensor data across 1 year in 2019. And I've also put there the personas or the cluster numbers that we generated with our research project for the Smartline participants, with the idea that if you have time at the end of the challenge, you could compare your own solution. We'll get more into detail about that, but with what we found to see, is there consistency across those different groupings, are there differences, and so on. And then there's also a README there that just explains the values and things in the files in a bit more detail. And then under the script demo, we've got instructions for running the script, which is very straightforward, but it's just there in case there's anything that's unclear from me running through it today, or you want a reminder to have a go later. There's a subset of the survey data, and then also the script itself. So I'll just move that down a bit. So here I'm using Google Colab, which some of you might have come across before. So you can run the script directly online. You don't have to have anything installed, but you can, if you want to, feel free to download the script and run it locally if you prefer to do that. So we run the script just by pressing the play button up at the top, and that runs through each section of the script in turn. So the first part is just installing the modules that we need. So we've got the K-modes library and the K-prototypes library as well there. So then we need to read in the data. In order to access the data, Google Colab needs access to the drive. So we go through an authentication process. So we just need to click on that link there, sign into a Google account, allow it to have access to the drive, and then copy that code that it's given and paste it back into the box in the script. And then it will access the data, printing out some of the data. We can see the first few lines of the data. Here I've just got two factors. I've got the age in a range of 5-year age range, and I've got an binary education factor, which is a 0 if the person was educated up to the age of 16, and it's a 1 if the person was educated beyond 16. And part of the reason for doing that binary split is we had low counts for some of the education levels, which in data means that there's a risk of disclosing individuals within the data set if you've got identifying factors. So if we've got numerical factors in the data, which we have, then they can be on they can have very different values from each other. So we don't want a factor with large values to add more to the distances that we calculate than a small valued factor. So we just standardize those scales by, here I'm creating Z scores, but there are various different ways that you could standardize the scale so that they're on a similar range. And here we've got the factors again where the age has been transformed into Z scores. And then these are the two lines that actually perform the cluster analysis. We need to tell it how many clusters do we want. So for the Smartline participants, we wanted to somewhere between 6 and 8 clusters, just to have enough clusters to make a difference, but not so many that it was just replicating the data set. So we actually got some summary across those. Here I'm just using 4 just to make it easier to visualize later when we plot the data. And then we also need to tell the algorithm which factors are categorical factors. So index 1, we've got index 0 and index 1. Index 1 is the education level, and that's a categorical factor, so it knows to use modes for that rather than the means. And so the algorithm conducts 10 runs on the cluster analysis, and then it returns the run that has the lowest cost or the lowest summed distances between individuals and their centres. And here the best run was number 6. So we can look at the centre coordinates that are returned by the algorithm. And here the coordinates are still on the Z-score scale. So we can reverse that calculation, and we can see the different ages of the centres of our clusters and also the different education levels. So with the mode, what we get in there is values from the actual data set rather than a mean average. Yeah, so here we've got 0 and 1. Then we can add the cluster labels to our data set so that each person gets assigned to a cluster, so we know who belongs to which cluster. And then we can plot the data in each of those clusters. So here I've plotted by the level of education, so that this represents in blue the number of people who are educated up to the age of 16, and in orange the number of people who are educated beyond 16 in each of the clusters from 0 through to 3. And then I've also plotted the mean age in each cluster. And you can see there's some patterns coming out of the data set. So in cluster 1, we've got the youngest age for all the people in cluster 1, but we've got the highest proportion of people who were educated beyond the age of 16. Whereas in the group with the oldest participants, they've got the highest proportion of people who were educated up to 16. So as I said, you can download the script if you like, or run it online, and there's a lot more information kind of explaining the process in a bit more detail on the information sheet in the main directory. So in our research project, we use more factors than I've just used, the two that I just used. We took the answers from the survey, and we included things like health, whether they've got mold in their home, whether they smoke, how much they volunteer. And we created these 8 personas, 8 different clusters. So for example, we've got David, who's a smoker with poor physical health. And then we've got Fred, who's a physically active volunteer with good mental health. The data set that's been provided on the Google directory and shared with you, it doesn't unfortunately contain all the factors that we used, partly because some responses have low counts, as I was explaining earlier, and could therefore risk disclosing the identity of an individual, partly because some of the responses have licenses for use, and so we're not allowed to share those data, and partly just simply because some of the survey data aren't publicly released yet, but they will be later in the project. We're hoping for that kind of towards March next year to release everything. So it'd be interesting to see your analysis of the data and the findings in how you decide to summarize and categorize across the different types of data. I think actually using a smaller number of factors could provide a different perspective and perhaps different groups of people to what we found. And as I said, I've shared the cluster membership that we had for each of the individuals, so you can compare the membership of your own analyses with what we found. And it would be interesting to know, are they wildly different when we involve different factors or different approaches? So the cluster analysis helped us create these groups of people who are similar to each other. But we also wanted to summarize across the sensor data that we've got by looking at those groups within our whole set of individuals. We wanted to use the personas to understand different aspects across these different types of people. And so after we generated the clusters, we looked at the different personas to see whether they have different sensor data across those different personas. So here we've got the temperature in the living room over 12 months. In 2019, for each of the personas, the temperature in the living room differed across persona. And we found that persona 2, which is David in orange, had a higher living room temperature than persona 8, Kathy in turquoise. And basically we performed an analysis of variance and ANOVA to test for significant differences across those. And we also added other layers to our personas using the qualitative data from the guided conversation and from focus groups as well, to the HAPPY project, which is about health and environment, public engagement, and via Cornwall Neighbourhoods for Change. So while you don't have access necessarily to those processes and data, it's the reason I'm saying it is because if you do go and read the paper about this research, then it kind of gives a background there. So the clustering analysis is useful not just for this kind of thing, it's just useful generally to create some similar groups of items or individuals. And importantly, it uses the values in the actual data set. So we're not deciding which categories we're making, it's actually driven by the data. So it's an objective technique to separate individuals into these groups, and hence in the title, without bias. So the groups can be used to understand the range of individuals in a certain setting. There's no point creating a category that doesn't exist within our cohort. And they can be used to understand the similarities and differences between those groups. We've also used the groups to select individuals to get a representative sample from across our whole participants. So we've gone back to them with specific questions about things. And we know that we're getting a range of people because we select from the different groups. Or as we've seen, it can be used to pool data for certain types or groups of individuals, like we did with the sensor data. And it's also commonly used, cluster analysis is also used for categorization. Once you've set up your clusters, you can then feed in new individuals and categorize them. So the challenge is for you to devise methods to kind of summarize the Smartline data that we have. How can you make it more accessible? How can we extract patterns from the data? So you can use cluster analysis. You could do it in the same way as we did, using the survey data to create the clusters, and then the sensor data to see, do the sensor data differ across those clusters? Or you might prefer to use the sensor data and cluster using that, and then overlay the survey data, or use a mix of the two to create the clusters. And if you have time, like I said, you could compare the membership of the homes in the Smartline ones with your own cluster solutions. Or it may be, having listened to me today, you can see another completely different technique that you might apply to this problem to find patterns in the data, to summarize across the participants, and kind of make their data tangible and accessible. So there's a long list of co-authors on the paper there to thank, but they're my colleagues, and thank you very much for listening to me. So I guess, have we got any questions?
Thanks, Tamrin. That's really, really interesting. And I think focusing on the specific challenge of clustering, I think it's helpful because there's lots of things you could do with the data, and I'm sure there's other kinds of data as well. I've got a few questions, and there's some already popping up in the chat. Mm-hmm. I might use the privilege of the chair to jump in with the first question. Sure. So how do you validate the quality of the clustering? Is there an approach you use to say, this is the clustering that the script or the algorithm has given us? What sense check do you use to say, yep, that's right, or actually no, that's something's gone off there? What's your approach there?
So typically, because it's data driven, you don't necessarily want to kind of predetermine what the group should be, okay. But that algorithm runs the process 10 times and returns the best results, because there are multiple different solutions that you could get because you're starting with random centers. And what I've done in the past is actually run it a lot more than that. So run that 10-fold algorithm, but also run that 10 times, and then select the best, the lowest distance between the individuals and their centers as the final solution, if that makes sense. Sure. So inertia is the measure of distances between the individuals and their centers, and inertia is often used as a measure to decide whether one solution is better than another, but it also can help inform, as you can probably see, the more clusters you add, the more the lower those distances are going to be, because everyone's getting closer to the cluster centers. If you've got more cluster centers, they're going to be closer to one of them. So at some point, though, that benefit of adding another cluster, kind of the rate of change of the gain that you get in that changes. And so that process can be used to inform the number of clusters as well. But there are other measures, not just inertia. There's measures of overlap between the clusters and things like that as well.
Yeah. Okay, I'll go through some of the questions in order. So first question is from Paul. Could you put the link to the slides in the chat, please?
Sure.
In addition to do that, would you be able to email me afterwards so I can share it with the group as well?
Yeah.
And while we're on that point, the point of contact for questions around this, would that be yourself? Is that the email address you'd like shared with the group?
Yes.
Okay.
So I haven't got that on the slides actually. Should I put it in the chat?
Put in the chat, and then if you email me afterwards, I can share it with the wider group because not everyone was able to attend today.
Sure. Yeah. Just
okay.
Type that.
Fantastic. Right. That's great. Next question is from Billy saying, I'm wondering how much did the qualitative data inform the final cluster choices versus the quantitative data, which are quite straightforward to cluster?
Yeah, so we use just the survey data to create the clusters, and then we use the qualitative data to kind of add information about those clusters. So if I just share my screen again.
Sure.
I can make that bigger. Sorry, it was already on display, so it didn't come up on the right screen there. But so these kind of summary statistics describe the center of the clusters, which are numerically based, whereas these three descriptive words here were actually overlaid from the qualitative data. So we had interviews, kind of semi-structured interviews with the participants, and it was across all, not decided by who was in what cluster. We just had those data across a subset of participants anyway. And once we had the clusters, then we took the guided conversation information within each of those clusters, sat down with a team of, I think there were about 10 of us, to try to agree together what themes were coming through from each of the clusters, and then drew out these three characteristics that adds a bit more information about that person, I suppose, but makes them more tangible in terms of a group. Hopefully that answers the question, but in short, we didn't use the qualitative data to cluster, we just used that to add more information to the clusters.
Sure, fantastic. Thank you for that. I'll move on to the next question, which is from Sam. Was there a specific logic to using 8 clusters, or is that just what fit the data? And then in brackets says, are you specifically looking for sets of 8 clusters, or is it worth looking at different numbers? So this is the general question of what's the right number of clusters?
Yeah, it's it can either be decided algorithmically, so by looking at, so each cluster you add, you get a decrease in the distances, and at some point that slope in decrease tails off. It's called the elbow. You kind of get an elbow-shaped graph where your gain isn't so much as it was previously. So you can either do it that way to decide the number of clusters kind of analytically, and run the solution for, you know, say 5 through to 10 clusters and see which way you stop gaining. We actually decided to go with 8. We thought between 6 and 8 makes a tangible kind of collection of personas. If you have more than that, it's quite difficult for people to process the differences between them. But then fewer than that, we might be over summarizing. So in terms of the challenge, no, I think actually it would be quite interesting to look at different numbers of clusters as well. And that could actually be something that you do yourself with. You could try, for example, 6 clusters versus 10 clusters, and then see, you can also do a measure of overlap between those to see, well, you can only do overlap measures when you've got the same number of clusters. So if you did want to compare overlap. I'm just trying to think. I think it can apply. Yeah, I think it would apply if you've got different numbers of clusters. You can then see the overlap between the solutions. It's a while since I've done it, so I've forgotten the process.
Yeah, no, it's a common question, isn't it? And the way I tend to think about it is too few clusters means it's not a useful clustering. Too many and you're just replicating the data. So it's finding the right generalization, which isn't too specific and isn't too general. And as you say, there's often a visualization with an elbow or a diminishing return,
Exactly.
which
That's
can be
the
helpful.
phrase,
The next question is, did any project objectives drive the qualitative evaluation of the cluster quality, since the clustering technique is unsupervised and stochastic in nature?
So the qualitative data weren't involved in performing the clustering. They were laid over the top. But what we tried to do with that is, I mean, with qualitative data, it is difficult to be objective, but we had about 10 project members got together for, I think, a day where we went through each of the guided conversations and drew out themes, and then we all switched with which cluster we were working with to try to cross-reference, I suppose, between ourselves. So it's working with qualitative data is not something I'm so familiar with. It was Tim Walker on the project who drove that process. And there is a kind of series of steps to it, but I'm not familiar with it myself, unfortunately.
Sure.
I was part of it, but didn't design it.
Yeah. So it's becoming clear that actually the clustering is based on the data that was collected, and the qualitative element is overlaid as a separate kind of process. There's a question from Abby. How will the clusters be used practically or operationally?
So we've used them with talking to participants. So in focus groups, allowing them to kind of depersonalize from questions and talk about concepts of a personality, rather than maybe talking about their neighbor or talking about themselves in person. We've also used them to sample across different types of people. So at the start of Smartline, we gave a smart tablet to everybody so that they could access their own sensor data. And we found that people didn't necessarily go and actually look at their own sensor data, even though we'd aimed to facilitate that. And recently we've gone back and conducted interviews with some people to say, why did or didn't you use it? And the way we selected those people was across the different personas. So we knew we were getting people of each type across a representative sample in Smartline. And also there are plans kind of when we connect with the SME, there's enterprise support, we can use the personas to kind of describe the participants and the data that we have across the different kinds of homes and different households that we have. So in terms of this challenge, I think what would be useful for us is to know how robust and replicable are these clusters. Do they still make sense in a smaller subset of data, or a different number of clusters as well? What are those patterns and overview summaries still coming through from the data that we've the different solutions?
Sure. Okay. I've got another little question. So the k-means approach is really common, and I just wonder if you've and maybe you haven't, because there's lots of things to do and you can't do everything. If you've looked at perhaps other approaches, so particularly when the number of dimensions grows, sometimes the k-means starts to become less effective. And some people use things like the TSNE approach, where you've got very highly multidimensional data, and being able to visualize the clusters in a way that shows what is actually close to what, even if it isn't accurate in terms of relative position. I wonder if you've done things like that, because that's probably what I will have a go at.
Right. So I've not heard of that. These are TSNE.
Yeah, I can't remember what it exactly stands for, but basically it's a method for taking high dimensional data, which is difficult to visualize because we like to see things in 2 or 3 dimensions at most, and it squishes it down to 2 dimensions, but iteratively moves things so that close things are close and distant things are distant. But what isn't preserved is the relative location. So you see the clusters, but if you run it again, you'll get the same cluster but located differently. It's just a great way of exploring to see if there are clusters in high dimensional data. And the other thought was, sorry.
Well, we considered, it sounds similar to principal component analysis, where you reduce your number of factors depending, create a new set of factors basically that reduces that high dimensionality. And there's 2 aspects to that. One, it takes away correlations within the data. So if typically with clustering, you don't want your factors to be correlated with each other, because then you've got two factors that are contributing to the same way in a cluster. But actually we didn't mind capturing that. If we've got a factor, it's important to us, so we didn't exclude anything for correlation purposes. But also we didn't use the kind of factor reduction processes, because we wanted to know what those factors represent. Once you start reducing and amalgamating over different factors, you lose the label that you can apply. So yeah, we did think about that at the beginning, because as you say, it's a very high dimensional space, and that can be problematic.
Sure. But the other related thought to that was not every cluster is circular, and some of the techniques are more helpful when the clusters are not spherical in nature. So you get those kind of iris data sets where you've got a cluster, and if you plotted it, it's a sausage shape rather than a football shape. But I'll certainly have a go at that as well. There's another question in the chat. Could the clusters be skewed towards older households that are more likely to participate, rather than representative of social housing tenants as a whole? Would there be a benefit for you to get a profile of a larger sample size, say 10K Cornwall housing households, for example?
Yeah, I completely agree with that. And I think that we kind of had 2 phases of recruitment, and it just so happened that the people who were, as you say, likely to participate and wanted to participate, people generally, when we've gone back and asked about motivations, they're participating for altruistic reasons, but they're also going to be the people who have a bit more time, which tend to be people who are retired. And we did then, in the second recruitment phase actually target more younger families. So we've got a few of those, but I think that the clustering process in itself reveals that. So that's where that data-driven aspect comes in. We're not creating a young family category or several of them because that just isn't in our data. So that's where we can also give that broad overview of the participants as these kind of central people or personas within them. Ideally, if we had more funding and more time, it would be lovely to extend across more households.
How much individuals are in the data at the moment that we can play with? Is it sort of 100 or so?
Thank you. There should be up to 300. Not everybody responded to every question. So when you've got missing data, you've also got options what you could do there. You could substitute the mean in or the mode in, or you could just remove that person from the data set.
Fantastic.
But yeah, there's up to 300. Yeah.
Okay. So I'm conscious of time. We have actually gone over time. So I'll try and kind of bring it to an end. Are there any other questions that anyone wants to ask? Either hands up or okay, we've had a good discussion there. So just in terms of next steps, if you're able to email me a link to the slides, which I think they include the link to the data as well, don't they? And the collab sheet and so on.
It's all in the all in that directory. Yeah.
Okay. And the best way for people to get in touch with you, and you've put your email address there. And in about 8 weeks' time, 2 months' time, I'll be kind of getting in touch with everyone with all the challenges to kind of get together and just to kind of share what people have been working on. So some people will go away and work quietly and then, ta-da, look what I've done. But some people will be kind of working perhaps in groups or just talking to you more directly. So I hope that's inspired people. I think that's a really, really interesting challenge. And thank you for sharing with us. I know you're very busy otherwise, so it's great to have some of your time and sharing some of the kind of interesting work that you're doing as well.
No, thank you very much for all your interest, and yeah, it'll be really interesting if you do take it on to see what you come up with. Thank you.
Yep. I'm definitely going to have a play with that TSME thing. Fantastic.
That's a good idea.
Great,
yeah,
thanks.
It'll be interesting.
Great.
Thank you.
Great. Thanks, everyone. Thanks very much. Cheers. Bye.
Bye.